Hello, welcome to the video. In this lesson, we're looking at section 11.1, where we're going to find circumference and arc length in circles. So circumference should be something that is a review for you all. The new concept that we're going to take a look at is arc length. To kind of get into the review of this, circumference is the distance around a circle, and depending on what information is given to you, whether you are given the diameter or if you are given the radius, the circumference is either going to be pi times it by the diameter, or it's going to be 2 times pi times it by the radius, again, depending on what information is given to you. There are essentially two different types of answers when you are looking at circumference because of the value of pi. If you leave pi in the, if you, sorry, if you leave pi in the answer, so like say, for example, the circumference of of a particular circle is 13 pi, and if you left the pi in there, this would be an example of an exact answer. Now, we know that pi is approximately 3.14. If we were to take 13 and times it by 3.14, we would say that, oh, the circumference is about 40.82. The 40.82 is an approximation because we approximated with our value of pi, and that's how we come up with that answer. So you need to be careful. Sometimes a problem may want the exact answer, or sometimes they may be asking for the approximation. Usually when they ask for approximation, they say, please round to the nearest tenth or nearest hundredth, in some form or fashion like that. All right, so here it says find each indicated measure. So it says the circumference of a circle with a radius of 9 centimeters. So since they gave us the radius, we are going to use the circumference equals 2 pi r. So in this here, it's going to be 2 pi times it by 9 because that's what they gave us. And our our exact result would be 18 pi centimeters. If we are looking for the approximation here, so we go 18 times by 3.14, it is about 56.52 centimeters. And if they don't specify, I'll take both answers. In this particular question, they want you to find the circumference of, I want you to find the radius of a circle with circumference of 26 meters. So again, they want you to find the radius. So what you're going to use is 2 times pi r. Well, they're telling you that the circumference is 26. So 26 is going to go here. I will notice this is, since there's no value of pi in the result of the circumference, 26 is essentially an approximation. So in order for us to find r, you're essentially going to divide 2 pi to both sides. So when you go 26 divided by 2 times it by 3.14, you get a value of about 4.14. So 4.14 in its meters is our value for r, which is our radius. The second portion of this lesson is talking about arc length. So arc length is similar to the circumference of a circle, but you are just finding a portion of it. So you're just finding the that that arc or that specific spot that they want you to find, depending on if it's the minor arc or the major arc. So arc length, you need essentially two pieces of information. One, you need to be able to identify the diameter or the radius. And normally, in this particular instance, it's better to have the radius, but if you have the diameter, just divide it by 2 to get the radius. And then we need to figure out what this angle is. Once you know what this angle is, so we'll call it theta. Once you figure out what that angle is, then you would divide whatever that angle is by 360 and then multiply it by the circumference of the circle, 2 pi r. So that is how you get that portion. So you're getting a fraction of the, you're getting a fraction of that angle measure. So for instance, here it says they want you to find the arc length of AB, which is right here. And they do give you that central angle, which is 60 degrees. And they give us the radius, which is 8. So to find this one, you're going to go 60 over 360, multiply it by 2 pi times it by 8, because that's r. And once you do all of the multiplying there, I'm just going to use approximations rounding to the nearest hundredth. It is about 8.37 centimeters. Here it says they want you to find the circumference of circle Z. So here's the thing. So they're telling you that this arc length here is 4.19, and we have that angle there, which is 40 degrees. So I got 40 over 360 times it by 2 pi r, which is in fact the circumference of a circle. So we are just simply solving for 2 pi r, and that is going to be equal to 4.19. So in this particular instance, all we got to do is I'm going to multiply 360 over 40, multiply 360 over 40, cross out here, cross out here. I got 2 pi r, which is the circumference. So 4.19 times it by 360 divided by 40 gets us 37.71 inches. So that is the circumference. Finally, they want you to find the arc measurement for RS. So RS is right here. They give us a radius over here, but they give us an arc measure of, oh, they want us to find the angle. So sorry. So in order to figure out what this angle is, we want to figure out what this angle is right here. Sorry. And to do that, we'll call that x. So it's going to be x over 360 times it by 2 pi times it by 15.28. And that's going to be equal to 44. Let me write it again. X over 360 times it by 2 pi 15.28 is equal to 44. All right, that's better. So in this particular instance, what I'm going to do is I'm going to multiply everything by 360 to get rid of this. So this is going to be 2 pi times by 15.28 times by x is going to be equal to 44 times 360, which gives us 15,840. And then this is going to be divided by 2 pi times by 15.28. 2 pi times by 15.28. So when I do that, I get I get a value for x, which is about 165.07 degrees. All right. So here it says the dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So like a revolution would be like, this is 1, this is 2. What distance would it cover if it went 15 times? So the revolution distance is going to come from its circumference. So we can discover that I can find the diameter of this right here. The diameter of this tire is going to be what, 5.5 plus 15 plus 5.5, which is what, 26. So essentially, our circumference is going to be pi times it by 26. So 26 times it by 3.14 gets us about 81.64. So that's one revolution. 81.64 inches is one revolution. So if I took that and multiplied it by 15, 15 revolutions would get us 1,224.6 inches. Now, in this particular instance, we're looking for the nearest foot. So there are 12 inches in a foot. I take 1,224.6 divided by 12, and it is 102.05, but to the nearest foot is 102 feet. So that is the distance the tire travels after 15 revolutions. Here it says the curves at the end of the track shown are 180-degree arcs of a circle. The radius of the arc for a runner on the red path is 36.8 meters. About how far does this track travel? They go once around the track. They want you to round to the nearest meter. Okay. So it's here. Curves at the ends of the track shown are 180-degree arcs of the circle. Well, that just means they're half of the circle. And it appears that we're looking at are we just looking at the red? That's what it seems like it is to me. So it looks like they're just trying to figure out the red one. So in yeah, that's what it seems to be. So they want to know how far you travel. So looks like from here to here is what, 84.39. So that happens twice. So 2 times 84.39 plus, they say it's essentially 2 half circles. So I'm just going to call it, so I'm going to say 2 times 1/2 times 2 pi, and they say that the radius is 36.8. So 2 times 84.39 gives us 168.78. I multiply all of these values together. I'm going to get 231.104. And then when I add these all up, I'm going to get 399.884, which is about 400 meters, which makes sense. Most tracks are 300 meters around the track. The very last thing that we're going to look at is being able to convert degrees to radians and vice versa. So in this particular model or this diagram here, it shows you 2 different ways. I only use this method and this method here, depending on if it's going from degrees to radians or radians to degrees. So if you got degrees to radians, what you're going to do is you're going to take whatever the degree value is, and it's going to be multiplied by pi over 180 degrees. When you take radians to degrees, it's going to be whatever the radian value is, and it's going to be multiplied by 180 over pi. Now, radians come into play a little bit more once you get into more trigonomic concepts, but this is just getting you familiar with both degrees and radians. They're the same value, it's just showing you in a different way. So last thing we're going to look at is they wanted you to convert 45 degrees to radians. So what you're going to do is you're going to take 45 and times it by pi over 180 degrees, and essentially 45 divided by 180 is going to be pi over 4 in lowest terms. For part B, they have it in radians. They want to convert it to degrees. So now you're going to do 3 pi over 2 and multiply it by 180 over pi. What it should do is the pi should cancel each other because one's in the numerator, one's in the denominator. And 3 times 180 divided by 2 gets us 270 degrees. And that is being able to look at circumference and arc length. Hope this helps. Till next time.